bucka. Ha You know the deal.
To understand word problems involving distance, rate, and time, let's take a look at a couple of examples. So here's a question that says a bus leaves the terminal and averages 40 kilometers per hour. 1 hour later, a second bus leaves the same terminal and averages 50 kilometers per hour. The question here is, in how many hours will the second bus overtake the first? So oftentimes with a question like this that involves rate, time, and distance, it's a good idea to build a chart and start to sort of fill in pieces of information that we know from the question. We're always going to be given at least 2 pieces of information in order to be able to solve a problem like this. So the first thing you'll notice is we're actually given the rates here. We're given the rates for the first bus and the second bus. So we can go ahead and fill those in. Now for time and distance, we're not actually explicitly given the time or the distance, but we are given a piece of information about the time. And usually when we're given a piece of information about time, distance, or rate, that's where we come up with our let statement, and we're going to go ahead and do that in the chart. So we know that the first bus leaves at a certain time, and it has been traveling for a certain amount of time. Now we don't know how long it's been traveling for, so since we don't know, we can go ahead and call that x. So we'll say let x represent the time the first bus has been traveling for. What we're told here is that the second bus leaves an hour later. So an hour later, a second bus leaves. So the question is, well, how does the time of the first bus relate to the second bus? Now, oftentimes students will naturally think, oh, well, it's 1 more hour. The thing is, though, it left an hour later. So if we think about this in terms of real numbers, if the first bus left at, say, 12 p.m., and if they met at 2 p.m., it's been traveling for 2 hours. If then the second bus, that means it left an hour later, that means it left at 1 p.m. And if they meet at 2 p.m., it's only been traveling for 1 hour. So the second bus has been traveling for 1 hour less than the first bus. So if we call the time for the first bus x, we have to call the time for the second bus x minus 1. So again, with a word problem like this, with a piece of information that we're given a little bit of a clue, that's usually where we come up with our let statement. Here we let x represent the time for the first bus, and therefore the second bus, the time has to be x minus 1. Well, now for distance, what we're going to do is we're going to start to develop our equation. To calculate distance, we multiply rate times time. Well, we have our rate here, which is 40, and we have our time, which is x. So to calculate distance, we would multiply 40 times x. Similarly, to calculate the distance for the second bus, well, once again, we would multiply the rate times the time. In this case, our rate is 50, and our time is x minus 1. So this is usually a first good step with a question like this, is to approach it with a table like this. Start by filling in the values that you know, the values that you're given, and then assign a variable to one of the unknowns and relate it to the second unknown, and then start to develop equation by using the mathematical relationship for rate, time, and distance. Now we need to actually write our equation. And the question is, well, how do we use these to write our equation? And we have to ask ourselves, well, how do the distances compare to each other? Suppose this is the terminal, and the first bus leaves, and it's going 40 kilometers per hour, and it gets to this point. The second bus leaves an hour later, and it passes the first bus here. Well, we can see that whatever the distance is here for the second bus is the same for the first bus. So these two distances that we have in this chart, they have to be equal when these two buses meet. So we can say then that 40x is the same as 50 times x minus 1. Just like word problems with coins, this is usually the hardest part. Coming up with your let statement and then creating your equation. Now what we're going to want to do is go ahead and solve this equation. So we get 40x. We can simplify the right hand side by doing our distributive law. multiplying 50 times x and 50 times minus 1 is minus 50. We're going to go ahead and bring that 50x over to the other side. So we have 40x minus 50x, because we moved that 50x over to the other side. It changes from a positive to a minus. And we still have the minus 50 on the right hand side. Now 40x minus 50x is negative 10x. Still equals negative 50. So at this point now we've done as much simplifying as we can do. We have to now try to isolate the variable. To get rid of times negative 10, we divide by negative 10. So that's what we have to do to the right hand side. And we end up with x equals 5. Well, what does that tell us? If we recall, x was our time for the first bus. So that means that the first bus has been traveling for 5 hours. The second bus has been traveling for x minus 1 hours, so the second bus has been traveling for 4 hours. The question here was, in how many hours will the second bus overtake the first? So what the question is asking is, how long will the second bus have to have traveled to pass the first bus? We can see that the second bus, the time that it will take is x minus 1, so 5 minus 1. Therefore, the second bus will take 4 hours to pass the first bus.